Hi everyone. So today we are doing surface area. We have done under geometry, we have done area, perimeter, and volume. So this is the last bit of the topic under geometry that we're going to cover, which is the surface area. And then we will start it off by doing a bit of recap from the other topics because they link up to this one and it will help understand the current one a bit better if we started with the recap. So, recapping volume, we know that volume measures the space inside a three-dimensional object, and then it's calculated with the length, the width, and the height. And in terms of formulas, when it comes to volume, we know how to calculate now the volume of a rectangular prism, which is given by length times breadth times height. And we know how to calculate the volume of a cylinder and a triangular prism and a cone. So these are relevant because knowing these formulas will help you understand surface area or how to apply the formulas into surface area. With that said, this is your first task. This is how it's going to work. If we were in a face-to-face lecture, this would be part of the work that you would do in class, and we will take a short break here to have everyone work this out. But because this is online, you are still going to do this in a slightly different way though. This is the first of many tasks that are going to pop up every now and then throughout the presentation. So we've just recapped on formula, which we now know. And as part of the recap, your first task is this one. What you're going to do is, because these tasks will appear every now and then throughout the presentation, you're going to write on a piece of paper your name and course subject as per normal, and then you will write task 1. Under task 1 there will be A, B, and then 2 A, B, C. And then there will be task 2. It will be just one task. It might be just one task under task 2, or it will be subdivided into A, B, C, and D's. So all you have to do, that you have to submit, would be task 1, your answer for A, your answer for B, your answer for 2A, your answer for 2B, your answer for 2C. So simply under task, your answer. It might take a bit of time having to work this out on a separate piece of paper, but you do not necessarily have to submit the working where you work out the answers. All I would want to see is task 1 and the answers properly labeled, and then task 2 and the answers, and so on and so forth. Cool. So this is your task 1 after recapping formula. These tasks, put them all together in one submission, which is due this Friday. And notice that this is not a worksheet like how we did in the first two semesters that were passed. It will be an exercise that was meant to be in class. So you just have a few more days to work on it instead of working on it in class. So these tasks together make up one submission that is due this coming Friday. There is yet to be a worksheet as per normal based on surface area that you're going to get next week during your TYT, which will be due after 4 days. I think that's what we had normally, or 5 days, but you will get a worksheet related to today's topic next week. Moving on, recapping now on the perimeter. We know that the perimeter is the distance around the shape. So perimeter of a rectangle, you have a length, the width, the length, and another width. You add them all together, they make up a distance around that flat shape. A typical example being, if you have a lawn, what is the perimeter of this lawn that extends 5 meters on one side and 3 meters on the other side? Because this is a rectangle, we know that opposite sides are equal. So the perimeter of this lawn would be 5 plus 3 plus another 5, which is opposite to the 5 that we know already, and plus another 3 that is opposite to the 3 that we know. It makes a total of 16 meters. Recapping on area, the way we calculated area was that if you have 1 meter on one side and the other meter on the other side, the area of that shape will be 1 square meter, or in short written 1 square meter using units like that. Another example, if it's centimeters, you have 1 centimeter and another centimeter. The area of that would be 1 square centimeter, or centimeters squared. In millimeters as well, same thing happens. You get 1 millimeter squared. Having recapped on area, this is task 2. So again here you would have under task 2, which is worth 6 marks, you have to find the measurements where you have question marks shown over here, and there. So these are not labeled in terms of A, B, C, but under task 2 you have 6 marks, 1 and 1 and 1 and 1 and 1. So to wrap up the recap section of this module, if you have the measurement of 2 sides, 1 centimeter and 1 centimeter, the area of that will be 1 centimeter squared. Compare that to a perimeter. Perimeter is the distance around a shape. You add them all together and you get your distance around. Volume, to calculate volume, which is the measure of the space inside a 3-dimensional object, calculated as the length by the width by the height. That links us up to surface area, and we'll see how those topics are relevant here. So a surface area, it is defined as the total area of the surface of a 3-dimensional object. Remember, volume was the measure of the space inside a 3-dimensional object. So this is the total area of the surfaces of a 3-dimensional object. So surface area is the 3-dimensional version of perimeter. Remember, with the perimeter you would add the distances of that you get around a three-dimensional object. So this one, you add the areas of all the surfaces. That's why it says surface area is a three-dimensional version of perimeter, but it only accounts for the outside of the shape. So in other words, the practical example or the practical definition would be surface area tells you things like the amount of material it would take to cover a three-dimensional object. That's why this topic is relevant to you guys as designers, because you are going to make products of any sort. In that way, you need materials to make that product. Another practical example could be if on a product itself you need to put a label on it, you need to know how much of the label goes onto what surface, how much material you need to put onto the product that's already existing. So the importance of surface area is you would know to calculate or to design your objects having in mind the material that you would need to make the product or to apply onto an existing product. So hopefully that makes sense and it sounds relevant to you guys, which it should. Cool, moving on. So continuing with the surface area, defining it. If you think about it, we now know that we can find the area of a square or a rectangle by having the height, having the width, and then you just multiply the two and your answer is in the square units. So area would be height by width. Then in a way, when we talk about the surface area, you can rephrase that by saying the area of the surface. Then because we're talking about three-dimensional objects, you can say the surface area is the area of all the surfaces that make up a three-dimensional object. And we know now, just to remind you again, that there are different types of shapes that you can have in a three-dimensional form. These are called space figures or solid figures, in other words. And then we've covered this. We know what prism is. There's also a pyramid, there's a cylinder, and a cone or a sphere. Those are the typical three-dimensional objects or solid figures or space figures. And by definition, you can go through this on your own, but the assumption is we now know what these three-dimensional objects are. And then we're going to look at a few of this in terms of surface area and how we calculate them. In general, to calculate the surface area of this three-dimensional object, the basic steps are you can either draw and label all of the faces of these objects. That's step one. Step two, find the area of each face. Then the last step is you add all of the faces together. So those three steps are basic steps that you need to calculate surface area of three-dimensional objects. Just to sum it up, the three steps involved are you draw and label all the faces. So that means you have to figure out how many faces of that three-dimensional object are there. Then after you figure that out, you find the area of each face. Having done that, you add all the faces together. That will give you the surface area.